Okay, welcome to another Ginger Mathematician video. Today we are going through the Specimen Paper 4. So I had lots of requests for this video after doing the Specimen Paper 2. So this is now a 2-hour paper, so it's slightly less than it is before, but now we can use the calculator. So make sure you have your calculator ready because we're going to need that for many of the questions we are going to look at. It is out of 100 marks. Let's get started. So question 1 here, we need to write down the integer values of x that satisfy this inequality. So if I said this out loud, this would be -2 is less than or equal to x and x is less than 2. But remember, we want integer values, and that's an important word. Again, that means we want whole numbers. So no 0.5s here, we just want like 2 or 5, those kinds of things. So the numbers that suit here is x can be greater than or equal to -2, so -2 is allowed. Then we have -1, 0, and 1. Notice 2 is not included because this is a strictly less than sign. 2 marks, that's quite nice to get us started. On to this question, so we have a construction question, and you're told that QR is 10 centimeters and PR is 11 centimeters. So what you're trying to find here with a ruler and compasses is this R over here. Now the way you would do this is you have your compass, you would open it up to 10 centimeters from this part and then make an arc. And then from this end you do 11 centimeters open and then do an arc. And then you find where they cross and then connect them up to make your triangle. Again, if you want some more information on constructions, I've got a lovely animation that goes through this with you. If you want to see that, then do let me know in the comments below. So that's questions 1 and 2 here. 4 marks, very nice way to get started. On to the next question, so we've got some simplifying here. So x to the power of 8, y to the power of 7, divided by x to the power of -1 and y cubed. So the way we do this is we separate it out into 2 parts. So we work out the x parts first. So we're doing x to the power of 8 divided by x to the power of -1. Now remember, if we're dividing, it means subtracting the indices, but we have to be very careful because we've got 2 minuses here. So 8 minus -1, that then becomes 8 plus 1. And so x to the power of 9. And now we do exactly the same with the y. So y to the power of 7 divided by y to the power of 3. So we minus those indices. That then gives us y to the power of 4. And we just simply put those two answers next to each other. So we get x to the power of 9 and y to the power of 4. Now it's funny, I've actually been through this next question, question 4, in my domain and range video. You can check that out above. So we're told the domain is -3, 0, and 2, and we want to find the range. This is a nice, easy question. We just put these numbers into our function. So I'm going to start with -3. So wherever I see an x, I'm going to put a -3. And if we work this out, again, you've got a calculator if you so wish. That's going to give us -9 minus 5. That's -14. And we do the same with each number. Again, you don't have to write out these steps, but it's quite useful to do so to build your confidence. So 3 times 0 is 0, that gives us -5, and then we put the 2 in. There we are. And that gives us 3 times 2 is 6, 6 minus 5 is 1. Now, what have we actually worked out from these numbers? So -14, -5, and 1. That is the range of the function. It's the output values. So all we do is just list them. -14, -5, and 1. So here the answers, x to the power of 9, y to the power of 4. And here if you get 2 of them correct, say you make a mistake with the negative numbers, you'll still pick up 1 mark for question 4. On to question 5. So we've got some work on bearings. So 2 towns here are shown on the map, and the scale of the map is 1 centimeter to 3 kilometers. So we want to find the actual distance between A and B. So the way you would do that is you'd measure this with your ruler. So again, I don't have a ruler to hand here, but say this was equal to, say, 11 centimeters. Then you could use the scale here. So 1 centimeter is 3 kilometers. So 11 centimeters. So we're going to times both sides by 11. And that then gives us the answer of 33 kilometers. So you'll need a ruler for this exam, even though there's lots of focus on the calculator. Again, you'd still need your ruler, your compasses, and your protractor. It's still important. And talking of that, we then need to measure the bearing of B from A. Now, this is always a little bit tricky. Few students make mistakes here. We always work from right to left. So from A, so we start at A, we go to our north line, and we keep going clockwise until we get to B. So we're actually looking for this angle. And you're going to need a protractor to measure that angle. If you've measured that correctly, it should be round about 120 degrees. Again, as you can see in the mark scheme, between 118 and 120 is absolutely fine. And now we need to calculate the bearing of A from B, so the other way round. Notice the words in the question are important. Measure means use your protractor. Calculate means use your angle facts that you know. And one angle fact that you should know really, really well on this iGCSE course is notice we actually have an interior angle. We have C angles. Now, the thing we know about C angles here is that these two angles add up to 180 degrees. Therefore, this angle needs to be 60 degrees. Now, why is that going to help us for this particular question? Well, we're looking for the bearing of A from B. So we start at B, we go north, and we go clockwise all the way around until we get to A. So we're actually looking for this big reflex angle here. And notice I've done some of the work for you already. Angles around a point add up to 360. So we just do 360 minus 60. No calculators needed here. And we get 300 degrees. And notice, not important in this question, but say we had a smaller angle, say we had 60 degrees, as a bearing we write it as 060 degrees. So that's really important. You want more practice on bearings? It's something that often gets forgotten about with all the stuff you have to do at iGCSE. Check out that video above. So you can see the answers here, and you can see they're pretty reasonable in terms of within 2 degrees. Whether you get to the answer or not. On to question 6 here. So we have a solid metal cuboid, has a volume of 600 cubic centimeters. So imagine you've got a cuboid. I like doing a little bit of sketching. And the volume of this is 600 cubic centimeters. And we're told the base of the cuboid is 10 centimeters by 12 centimeters. And we want to find the height. So remember, the volume of a cuboid is base times length times height. So in this case, 10 times 12, there we are, times height. We know the volume is equal to 600. So it's just an equation to solve here. 10 times 12, that's equal to 120. And so 600 divided by 120, remember, to get rid of the number in front of the h, we need to do the opposite, which is divide by 120. On both sides, we cancel here. That gives us 600 divided by 120. I would hope you don't have to go to your calculator here, but we get the answer of 5. Okay, so we don't need to necessarily use the calculator here. We do, however, for question B. So the solid metal cuboid is melted down and made into 1,120 spheres. That's a very specific number of spheres, each with radius 0.45 centimeters. Find the volume of metal not used in making the spheres. So the first thing I'm going to do is work out the volume of the spheres. Now the formula for the volume of a sphere is on your formula sheet. Now you have a formula sheet, so please do use it, but I'll be nice here and give it to you straight away. That is 4/3 pi r cubed. So our radius is equal to 0.25, so we've got 4/3 times pi times 0.45 cubed, and we have 1,120 of them, so we need to times one sphere by then 1,120. This is the first opportunity to go to our calculator. Now I have my handy emulator here. This is an ordinary class whiz. It does fairly basic functions. Again, so if you don't have a very complicated calculator, you can still follow what we do. So let's type this in. So we have 4/3. So 4/3, and then times pi, know where your pi button is, so shift and down the bottom here, times 0.45 cubed. Notice all the units are in centimeters, so there's no changing units, which is handy. So here, and then we're going to times by 1,120. Now usually it gives you in terms of pi. If you want to change this to a decimal, again, you can just press this button here. So we get 427.5. So I'm just going to write that down. with my pen function, there we are, 27.5. But of course we want not used. So we want what's not used here. We take the total amount of volume had, which is 600, and then minus the 427.5 dot dot dot. Now to make sure there are no rounding errors here, a nice handy function to use in your calculator, get a nice calculator hacks video, but this is really useful, is 600 minus answer. That means you won't lose any decimal places. So we have 172.492. 492 dot dot dot. Generally we round to one decimal place, so we have 172.5 as our final answer for the 2 marks. So you can have a look at the mark scheme here and where we pick up all 4 marks for that question. Okay, question 7, a bit of probability here. So on any day, the probability that it rains is 1/3. When it does rain, the probability a mirror goes fishing is 3/5. It doesn't rain, then mirror goes fishing is 3/4. Makes sense, yeah? If it doesn't rain, you're more likely to go fishing. In a period of 60 days, how many days is it expected to rain? Nice easy formula here. We take the number of days and then multiply by the probability of it raining, which is 1/3. And that's going to give us then 20 days as our expected value. So nothing too tricky here. You get 20, you get the 1 mark. Now notice it's quite tempting to go straight into a tree diagram, but part B actually has a tree diagram ready for us. So we need to complete the tree diagram here. So one thing to realize here is that the columns, so to speak, always add up to 1. So if the probability of raining is 1/3, then probability not raining is going to be 2/3. And then each pairs here always add up to 1. So probability of it fishing is 3/5, therefore not fishing is 2/5. And now we have to be a bit careful. We have to read the question. When it does not rain, a mirror goes fishing is 3/4. So not raining, fishing, so that's 3/4, and therefore this is 1/4. So be careful with that last pair there. You don't just copy it across. There is a condition here. And we want to find the probability of any day a mirror goes fishing. So there are 2 ways we can fish. We can either go rain and fish. So I'm going to call this R and F. So that's 1/3 times 3/5. That gives us then 3/15. Not going to simplify yet my fraction. Notice multiplying fractions, we times the top and we times the bottom. And we have the possibility of not raining and go fishing. So that's 2/3 times 3/4. And that will then give us 6/12. Now here I'm looking to see if I've got a common denominator. I don't. So I can simplify these fractions. So I've got here 1/5 and here 1/2. And if we want to work out the probability of just fishing, then we want to add these answers together. So the probability of rain and fishing plus the probability of not rain and fishing. And that's equal to 1/5 plus 1/2. Now again, you could use your calculator here. Again, just because there is a non-calculator paper doesn't mean you shouldn't use the calculator when you want to. So if we do 1/5, or 1/5, sorry, plus 1/2, again, you can do it pretty quick in the calculator. It'll do it for you, again, and it'll work it out straight away as 7/10. Okay, which gives us all the marks, the 3 marks for this question. Again, if you're feeling a bit not so confident with fractions, you should be practicing that for the paper too, but you can always use this as a backup as well. It's a very useful technique. Okay, so here's the mark scheme. Again, everything that we've done so far. On to question 8, and this is one I've had a fair few questions about. So this is a shading inequalities question. However, a shading inequalities question is not necessarily the same as linear programming. And I often find students get confused. They think the question is essentially the same. So shading inequalities is still on the course, but to do something with it, like find the maximum value of something, for example, that is no longer in. So just keep that in mind. You still need to be able to shade inequalities, and this is a good example. So on the grid, first of all, we need to draw the lines y equals x and x plus y equals 7. Now I'm looking ahead here, and notice all these signs here are greater than or less than or equal to, so I want solid lines generally. Now y equals x is an easy one to draw because y and x have to be the same. So 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. You see the pattern here, and we can just get the ruler and connect these up. So that's useful. Now this one here, x plus y is equal to 7. This is a bit trickier to do. There's a couple of alternatives. First of all, you could rearrange to make y the subject. So we minus x from both sides. We get y equals minus x plus 7. And then we could use the mx plus c formula, or perhaps slightly easier, let's think of pairs that add up to 7. So if we have 3 and 4, for example, that adds up to 7. 4 and 3 does, 5 and 2 does, 6 and 1. And notice you can generate the line pretty quickly by doing this process. Okay, and again, just like before, we join them up. Obviously, you're doing this with a ruler, of course, at home. And now the region R satisfies these inequalities. So I do this one at a time. So y is greater than or equal to 0. So we've got our y and we want it to be greater than or equal to 0. So this direction. Y is less than or equal to x. So the line we drew at the start, we want that to be less. And x plus y is greater than 7. So we want this line here to be greater than. So once it's to the right here, we want to go down here and up here. So we need to shade in this part here, like so. Again, in an exam, I'd make sure that is far more neat as well. Okay, so there we are. There's our mark scheme here and how you pick up the 4 marks. Super, on to question 9, and this is always a big topic on iGCSE generally, and that is speed time graphs or distance time graphs. So you need to know how to work with both. Here we have a speed time graph. So that's important. As soon as I see speed time graph, I'm thinking about acceleration already before I even do the question. However, this question wants us to do the deceleration. So obviously reducing our speed here and between 10 and 13 seconds. So as soon as I see acceleration or deceleration, I'm just thinking to myself the gradient. So we have 10 and 13. So we have our triangle already. So the height of it is equal to 8. This is equal to 3. And so we always do rise over run. So 8 divided by 3. Now, I generally would keep this as a fraction. And they do as well. Again, you could also do a decimal, but fractions are generally easier to work with. Total distance traveled. So as soon as I see this phrase, I'm just looking for area under the graph. So again, trigger words and just working out what the trigger word is. So to work out the area under the graph, we have a rectangle. So we have 8 times 10. So this here is equal to 80. Now we have a triangle. So that's going to be 8 times 3 divided by 2. Base times height divided by 2. That's equal to 12. And then we just add those together. So 80 plus 12 is equal to 92. So we put in 92 meters. I think that's a very nice, easy 3 marks. If you're liking this video and these explanations making much more sense to you than what you've seen before, then please do like and subscribe so you can get more iGCSE content, or even when you go onto A-Level at IB, you have access to all the A-Level and IB content that is out there on the channel. Okay, on to question 10, 11. This is where we start getting a bit trickier here. Now, they like these kind of factorizing questions where they split it into 4 terms. They generally do this nicely, so it can actually go into double brackets. Let me show you what I mean. So I'm going to draw a line down the middle. So I'm going to separate it into 2 parts. Now here, I'm going to see what can I factorize this 2x plus 6. What does the 2x and the 6 have in common? Well, they both have a 2 in common. And then let's work backwards. So what do we multiply 2 by to get 2x? Well, that's x. What do we multiply 2 by to get 6? That is 3. Now here I do exactly the same process. What do they have in common? Well, they have a minus 3, goes into both. They also got a y as well. So we're going to take out minus 3y because they have that in common, and then work backwards. So what do you multiply minus 3y to get minus 3xy? That's x. What do you multiply minus 3y by to get minus 9y? Well, that's just plus 3. Now they're always set up these questions so the brackets will always be the same. So notice we have x plus 3 in both. So our nice little step for the last part to factorize this is we take the x plus 3 and put it in 1, and whatever we're left with, so what I mean by that is whatever we're left with outside, so 2 and minus 3y, we then put into our second bracket. So our final factorization is x plus 3, 2 minus 3y. Now, if you think that's a little bit of mathematical trickery, you could always use FOIL and check your answer by expanding. So first, outside, inside, last, and then you can double check in the exam you're actually getting this expression at the end. This is a 2 marks. That's often the difference between an A and A star candidate, so do keep that in mind. Okay, on to Venn diagrams. So I've got some interesting notation here. So basically what it says here is that everything in our diagram adds up to 20. So that's useful to know. They've actually given us this number already. So the number of elements of A or B, but not that, is equal to 3. So notice they give that to us already. And it says the number of elements in A is 10 and the number of elements in B is 13. However, it doesn't tell us anything about the intersection. So the way I generally do these questions is I put an X in the middle, and then the number of elements in A, well, that's going to be 10 minus whatever's in the middle. So 10 minus X. I do the same with B. So it's going to be equal to 13 and minus whatever's in the middle. And I know because I've got 20 elements in total, 3 outside. So basically A or B. So all this stuff, let me just put a circle around this. All this stuff here needs to add up to 17. Because 3 outside and then 17 then makes 20. So what I'm saying here is 10 minus x plus 13 minus x. So all the stuff that I've just put in the circle has to add up to 17. And this is a nice, easy equation to solve. Notice we have a cancellation. So minus x and plus x disappear. That means 10 plus 13 is 23. Minus x is equal to 17. And again, you can use equation solving here, but then we get x is equal to 6. Now, if you're not happy, like, I'm not so sure if x is 6 or 5 or something else, well, what we can do is just put it in. So x, we've decided, is 6. 10 minus x, so 10 minus 6 is equal to 4. And 13 minus 6 is equal to 7. Does this match the information we have? Well, the number of elements in B is 13. 7 plus 6 is 13. Number of elements in A is 10. 6 plus 4 is 10. So we're all good. So now to work out this. So the number of elements in A and B, so that's just the intersection. So that is the 6 that we just worked out. So we can pop that down. This is a bit more complicated. So not A, so nothing in A and B. So the crossover between not A and B, that's just going to be this section here. So that's just going to be equal to 7. If you didn't like this last part, so part B, I've done a fantastic video on Venn diagrams. It's got about 100,000 views now on YouTube. Again, really do check that out above. That explains how I can get to that answer so quickly. So those are the answers for question 10 and 11 here. On to question 12, and this is a very, did I say very? Typical question for calculator papers, so now just the paper 4, for iGCSE 0580 Maths. And that is this phrase, estimate of mean. Soon as I see estimate of mean, okay, there are 2 things that I always do. That is first, I find the midpoint of the category, so halfway basically. So what's halfway between 100 and 150? Well, 125. Halfway between these 2 numbers, 155. 160, 165 is 162.5. And 165, 185 is 175. So as soon as I see estimate of mean, I want to find the midpoint. That's my first step. And my second step is to do the midpoint times frequency, which is what we're going to do now. So I'm going to try my best to fit it underneath so it's nice and smooth. So midpoint times frequency. Now this is where your calculator is very useful. So let's get our calculator out to do a lot of the heavy lifting. So 125 times 7, that's equal to 875. I wouldn't be surprised if you skip the next part of the video for the next minute or so. But this is the process you go through if you want to recap. So 155 times 30, 4,650. And next one. this would be a great chance to go into comments and say if you're enjoying this video. 60.5 times 41. Key thing is not to make a mistake and be overconfident. So 6,662.5, and then the last one. It is a 4-mark question, so they do give you the time to do this. Unlike the 0607 course where you're expected to use your graphical calculator. Cool, so we have all those numbers, and now to work out the estimate of mean. So we take those numbers, so 875, 4,650, plus 6,662.5, plus 3,850, all divided by 100, and that will give us our estimate. And this is where someone shouts in the comments, "Oh, you've made a mistake." And it can happen, but let's see where we are. So 6,662.5, make sure we type this in correctly so I don't get those comments, and then divide that by 100. I'm getting 160.375. Cool. Notice here they give an exact value. So if you're getting something quite nice, which is a fairly nice number, then I would just give all the decimals here to get the 4 marks and not take any risks, essentially, with this question. Okay, on to question 13. Again, unlucky for some. So the diagram shows a quadrilateral, 4-sided shape, formed from two triangles, ABC and ACD. ABC is right angled. Yep, we've got a right angle here. Calculate BAC. So as soon as I see right angle and I have 2 sides and I want to find a missing side, we are using Pythagoras. Now, generally, I'm getting ahead of myself because I thought we needed to work out the length AC, but we're now looking for angle BAC. Okay, so BAC. So this angle here. Now what I'd like to do for students is just rotate it round so it makes it a bit easier to see. So we've got 12 centimeters, 14 centimeters, and we're looking for the angle at the top here. Let's just call that X. Now if we're looking for angles and right angled triangles, then we need to be thinking about SOHCAHTOA, sine, cosine, and tangent. The way we do this is label the sides. So we have 14 is the opposite side because it's opposite the angle, and 12 is the adjacent side because it's next to the angle. And because we've got O and A, we're going to be using TOA, so we're going to be using tan. So to work out tan of the angle, I'm going to call it X. Opposite over adjacent, so O divided by A, so 14 divided by 12. Biggest mistake students make here is do 12 divided by 14. And of course we want the angle, not the tan of it, so the opposite of tanning is the inverse of tan. So that gives us then X is equal to the inverse of tan, 14 over 12. And let's now go to our calculator. Now also one thing to make sure for your calculator is make sure it says D at the top. You want it in degrees. If it says R, that bad things happen. So make sure you're aware of that. So we go to Shift Tan, and then we do 14 divided by 12. Gives us 49.398. 49.398. So that's going to be to 1 decimal place 49.4 degrees. Again, any of those answers will give you then the 2 marks. Okay, on to question B. So we've got 4 markers, so it's going to take a bit of work here, and that's to calculate BD. So let's work out where is BD. Calculate BD. So the length across here. Okay, so let's just draw that in. Usually they give you the lines within the question, but sometimes not. Okay, so usually it's based on something we've already worked out. And notice we've already worked out this angle here, this 49.4 degrees. So it has to be something related to that. That means we actually have this entire angle here. We've got 2 sides. We've got the angle in between them, and we're looking for a third side. This sounds like a classic cosine rule question. Now, the cosine rule is equal to c squared equals a squared plus b squared minus 2ab cos c. Make sure when you're doing the cosine rule, you put a cosine. That's one thing that some students do. Now, we just need to label the sides here. So BD is what we're looking for. A and B are our smaller sides, and then the angle in between is just these 2 angles added together. So To work this out, c squared is equal to 15 squared plus 12 squared minus 2 times 15 times 12 times the cosine of the entire angle in between. So that's 62 plus 49.4 dot dot dot. Okay, I'm doing that because I'm going to be using that in a moment. And to work out c, I just need to do the square root of everything I've just written. So that's all the working I need to do. I don't need to do too much extra, but now it's about using the calculator really effectively. So watch this carefully. So first of all, we have a square root. Then we're going to have 15 squared plus 12 squared minus brackets 2 times 15 times 12 times the cosine of 62 plus answer. Remember, I've still got the answer from part A in my calculator. 2 lots of brackets to finish off. Press equals, and then we get the answer directly here of 22.38. So it's correct, which is always good. So 22.36 dot 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 dot, and that rounds then to 22.4. for our 4 marks. So notice it's a 4-mark question, so it does take a bit more work and a bit more visualization, but I'm not writing a lot of working here, yeah? So notice, just writing this down and doing it more or less correctly, I'm picking up 2 marks. That's all I need to do. Then as long as I put it into my calculator carefully, I will get those 4 marks afterwards. Super. And now we've got a shortest distance question, which is very common. So as soon as I see shortest distance, I'm thinking of a perpendicular line. That's all I'm currently thinking about before I look at the actual diagram itself. So from D to AC. So from D to AC. Okay. So what we're talking about here, and let's just put this in a different color so we can see what's going on. I want to draw a line. So something looks like this. That's the shortest distance from this point D to the line. And if it's the shortest distance, it's always at a right angle. So essentially, we've now created a new right angle triangle where this angle is 62 degrees, this is 15 centimeters, and we're looking for the shortest distance, this blue line. So we're looking for this. Again, we're just going to use SOHCAHTOA like we did before. So here we've got the opposite and the hypotenuse. So we're going to be using SOH. So that means then that sine 62 is equal to O, so x over 15. So to get x on its own, we multiply by 15, so we get 15 sine 62. So for this question, all we need to do is work out 15 sine 62, which our calculator can do very easily for us. Again, we've checked everything's in degrees, so it makes things easier. So we just type in 15 sine 62 equals 13.24, and that gives us 13.2 to 1 decimal place. To think that this is actually a 3-mark question, it's more the visualization of when you draw that perpendicular line, it makes a new right angle triangle, and then you just use your normal SOHCAHTOA to get 13.2. Okay, on to question 14 here, a nice big percentages question. So Hong here has $4,000 to invest and splits up into 2 different investments. So we have $2,000 at 2.5% per year simple interest, and then we have $2,000 at a rate of 2% compound interest. And we want to find the value of each of them after 8 years. So I'm going to split this into 2. We'll do simple over here, and we'll do compound over here. So let's do simple first. So the first step here is we find 2.5% of the initial amount, so of $2,000. Now, how do we do that on the calculator? So we go to our calculator and we turn 2.5% into a decimal. So we're going to divide that by 100. That's going to give us 0.025, and then we multiply that by 2,000. So that gives us $50. So we get $50 is every year is going to be the interest, and then because it's 8 years, we're going to be doing $50 times 8. So that's going to be $400, which means the investment after 8 years, we simply add on the interest to the initial amount, so the 2,000, and that gives us then $2,400. So let's write that in. Now compounding in some ways is actually easier to work out because what we do is we change 2% increase into a percentage. Well, a 2% increase is the same as 102%, and as a decimal that's 1.02. Now why is that helpful? Because now we just put it into the formula. So we do 2000 times 1.02 to the power of 8, so because we're doing it over 8 years. Again, we can use our calculator. So we have here 2000 times 1.02 to the power of 8. Use this button here, and then we get 2,343 point. There was a point something. Let's have a look. 0.3187. 3187. And generally with money questions, we round this then to nearest pence or nearest cent. So 2,343.32. There we are. Again, if we have a look at the mark scheme, again, that is generally what is considered the correct calculation here for all 5 marks. A lot of marks just for this first initial question. Now part 2 is the overall percentage increase, that's important, of the $4,000 investment at the end of 8 years. So what we're going to do is going to add these two things together. So that gives us, total is going to be 4,743.02, and we want to find the percentage increase of that. Well, the difference between our initial investment and this is just this part here, so 743. So a percentage increase is going to be 743.32 divided by the initial amount, so 4,000, and then we times by 100. Again, a formula you just need to learn off by heart, and not given usually on the formula sheet, but is important to be aware of. So we have 743.32 divided by 4,000, not 40,000, times 100, and that gives us then 18.583. And again, we like rounding here to 1 decimal place. So as you can see here, you just get 18.6. Again, usually don't get marks taken off if you do it to 2 decimal places, but just a good habit to get into. Part 3, to find the number of complete years it takes for the compound interest investment of $2,000 to become greater than 2,500. Now, because we are working with 0580, you could do this with logs as well, but we'll do a trial and error approach, which is generally easier to remember. So let's get the information we have so far. So after 8 years, we had 2,343 ... and we want to get to 2,500. So let's try 12 years. Let's start with that and see where we're at that point. Now the formula we're using is what we used in the first part. So 2,000 times 1.02, because we're going up by 2% to the power of 8. So it's this formula here. But we're now going to change this number and see if we can get that point where we cross the $2,500 threshold. So sometimes this can be quite frustrating because you can't quite see the number that you need. So let's start with 12 just to see where we're at. So 12, that gives us, oh, we're straight over to 2,536. ... So we need to try 11 because maybe 11 is enough to get over $2,500. So if we go back and change this to 11, I like this feature. 2,486. Okay, that's pretty good. So that means 12th year is what's required in order to cross that threshold of $2,500. Again, you need to see some kind of trials here, again, in order to show you've actually worked this out. Okay, and the last part, so Alain invests $5,000, so a completely different amount here, at a rate of R% per year compound interest. That's important. At the end of 15 years, the value investment is 7,566. So I generally use this formula of total equals initial times multiplier to the power of number of years. So that's what we've been using in this question. So all we need to do is put in what we know. So initials $5,000, the total is 7,566. The multiplier we don't know. Okay, so let's call that M for the time being. The number of years we know is 15. Okay, so this is just an equation to solve here. So let's get the M on its own. So we divide by 5,000 on both sides. Now it's not rushing to my calculator straight away. I'm happy to just write it as a fraction. And now the opposite of raising to the power of 15 is the 15th root. Not often in an iGCSE paper I get to say that. So we want to work out this. So let's use the calculator here and show you first of all how you do a 15th root. So you want to use this button here, so shift and here, so we can change what root we want, and then we have a fraction of 7,566 over 5,000. Now this is not the answer, but it's going to help us work it out. So 1.027999. 1.02799, and in order to actually work out the interest rate, we just need to take this part here. Essentially, we divide through by 100, so we're going to get 2.799 ... percent. Again, we generally round to one decimal place, so I will go with 2.8% here. Again, both answers are absolutely fine to give you all 3 marks. That's a really good chunky question, and in some ways not actually that complicated, but you just have to read it through carefully. Compound interest, simple interest, what you need to do. So yeah, whacking 13 marks for that question out of 100. That is quite a bit. Okay, on to 15 here. So we've got a little bit of algebra. So y is equal to the square root of u squared x. Find the value of y when u is 7, x is 25. So we put it into here. So we have u is 7, so 7 squared times 25. So that gives us then 49 times 25. I mean, we could do non-calculator methods here, but I think we can just use the lazier calculator approach on this paper. So we just type it in. So we get the square root of 49 times 25. Yeah, and that gives us 35 as our answer. And this is very typical, this rearranging, so look out for this, to write x in terms of u and y. So we want to get x on its own. So the way I generally begin this is flip it over. So I already have x on the left-hand side before I do anything. And now we just chip away at it to get x on its own. So this square root's annoying, so we're going to square on both sides. So it disappears. That gives us then u squared x is equal to y squared. And now we can just divide through by u squared, so we get x is equal to y squared over u squared. Now I like writing it as a fraction. I assume the answers would also like that. But notice you've got this or equivalent. So if you wrote it, for example, like this, that is also okay for the 2 marks for this question. Okay, question 16, a bit of coordinate geometry. So A is 0.72 and B is -5.8. Calculate the length of AB. Yes, this is a very standard question. When I do these questions, I like to just draw a rough sketch so I know what's going on. So A is 7.2, so 7.2 over here, and B is -5.8, so more here, but up here somewhere. So B, this is -5.8, and this here is 7.2. And we want to find the length of this. As soon as I say a length with coordinate geometry, I'm thinking Pythagoras, and I'll show you where that's going to come. So what we do is we draw in a right angle triangle. And we can actually use the numbers that we have here to work out the lengths of our triangle. So notice here we've got -5 and 7. So the difference between -5 and 7 is 12. The difference between 2 and 8 is 6. So to work out AB, I generally recommend students do this in one smooth calculation. We do the square root of 6 squared plus 12 squared. There's no need to break this up in any smaller steps. So at this point, again, just go to my calculator. I say this a lot, compared obviously to the previous video. 6 squared plus 12 squared. And see what we get here. So we get 6 root 5. Generally, I think they'd expect a decimal. So 13.416. Okay, I'll put in brackets here, 6 root 5. Again, just generally round to one decimal place, so we get 13.4. Notice no units here because we're not given if it's centimetres or something else. Notice they don't actually give the third answer because on this paper you're expected to use the calculator. And now we need to find the equation of the line that is perpendicular to AB and passes through this point. Okay, very standard question. So if we work out the gradient of the line AB that we just were doing here. So remember, it's just rise over run. So remember, get this the right way around. So we have going 6 down, so minus 6 over 12, so that's equal to minus a half. So perpendicular to AB, we do what's called the negative reciprocal. I've talked about this a lot in my videos. So we flip the fraction, so 2 over 1, and then change it to a positive. So it's going to be 2. So essentially what that means is our line is going to have the equation y equals 2x plus c. That's what we spent a lot of effort trying to work out here, the gradient of the perpendicular line. And now we have this point, so we can work out the c. So when x is minus 1, y is 3, that gives us 3 equals 2 lots of minus 1 plus c. 3 equals minus 2 plus c. Therefore, c is equal to 5. So our final answer is y equals 2x plus 5. Yeah, I've done a lot of practice in my big coordinate geometry video where I go through lots of these kinds of questions. Again, I recommend you check that out on the channel. Okay, so we have a nice 7 marks here. Very nice when you get this feeling of, 7% here, 13% here. You're really building up towards that A and A star grade. On to question 17, nice little 2 marker here. So the area of the triangle is 50 square centimetres. Calculate the value of sine x. Okay, slight twist. Now remember, the area of a triangle, we have 2 formulae. But one that gets forgotten about is the half AB sine C. So if we use what we have here, the area is 50. We know the 2 sides are 18 and 30. And then we have sine of the angle. And that's what we're looking for here. We're not looking for x, we're looking for the sine of the angle. So can we simplify this? Well, half of 18 is 9. So we can simplify that down. And at this point, we can just use the calculator. So I've got 13 times 9. 13 times 9, that's 117. So sine x here is just going to be equal to 50 divided by 117. Would they want it as a decimal? That's a good question. They do like it as a decimal. Okay, so if we want this as a decimal, which generally on a calculator paper you should do, I'm just so used to leaving things as fractions, it makes things much easier. Okay, we just press the decimal button, get 0.42727, which they're happy with that kind of rounding. So here they've done it to 3 significant figures. Okay, nice little question. A little bit unusual on the paper 4, but I guess with the papers changing slightly, again, you have to be a little bit aware of that. Okay, a bit of equation solving, question 18. As soon as I see 2 fractions with an equal sign, I'm thinking of cross multiplying. So I'm going to cross multiply here. So we have 3y times 4, let's just write this out, is equal to 3 times 2y minus 1. 3y times 4 is 12y. Now we have some expanding brackets. So 3 times 2y is equal to 6y. 3 times minus 1 is minus 3. And we're getting there. So we want to get y on its own. So we bring all the y's to one side. So we minus 6y on both sides. This cancels, giving us minus 3. 12y minus 6y is 6y. And now we want to divide by 6. That's the opposite of multiplying. This cancels, giving us y equals minus 3 over 6, which simplifies to minus a half or minus 0.5. And what I've been noticing so far is they're liking decimals. So I'm going to put it as 0.5. And now they put it as a fraction. Okay, there we are. Okay, question 19. So the cross-section of a prism is an equilateral triangle of side 6 centimeters. Again, I just draw a sketch with these kind of questions. So here is our prism. Now my drawing is generally terrible, but it's good enough, yeah? Equilateral triangle of side 6 centimeters. So this is 6, this is 6, this is 6, okay? So I'm just putting the information in, and we've got a prism. The length, okay, is equal to 20. And what do we need to work out here? The total surface area of the prism. Okay, so let me draw this in a bit better. Okay, so I've got my my prism here. So the first thing I'll do, I'll work out the rectangle area. So this one, and then the bottom. And they're all going to be the same. They're all going to be 20 times 6. So to work out the rectangles, let's just put it that way. I'm going to do 20 times 6, but I'm going to do that 3 times because there's 1, 2, 3. So that gives me 120 times 3, which is 360 square centimeters. The tricky part is going to be these triangles. Yeah? So let's have a look at these triangles. So if I have an equilateral triangle, now there's a few different ways we can do this. I think since we've used this formula before, each angle here is equal to 60 degrees because equilateral, and we can actually just use the area of the triangle formula we used in the previous question, the half AB sine C. So the area of this triangle is a half times 6 times 6 times sine 60. So again, we can just put that into the calculator here. So 0.5 times 6 times 6 times sine of 60. You could also use Pythagoras here as well. So we get 9 root 3 or some decimal. So 15.588. 588. However, we've got 2 of these triangles, so we need to do the 15.588 times 2 and then add the 2 results together. So we can do that at the same time. So we times this by 2, add 360, and that gives us then 391.17 ... Yeah, again, 1 decimal place is fine, so I would do this as 391.2 square centimeters. Okay, the tricky part is actually working out the triangles. Alternatively, what you could have done for the triangles is split it into 2 and done a perpendicular and then used half base times height by Pythagoras. That was the alternative here. Okay, so you can see the mark scheme there. On to question 20. Aha, some differentiation. I haven't done that for a while. So find the value of k and the value of u. Okay, so I got y equals 2x to the power of k plus ux power of 7. This is a bit different than previous differentiation questions. So if I work out dy by dx, remember the rule here, we bring the k to the front and times it by 2, so we get 2k. And then we reduce the index by 1, so k minus 1. And then we do the same here, so we bring the 7 to the front, so we get 7u, and then reduce this by 1, so x to the power of 6. Okay, and then we just compare what the answer is to what we have. So let's start with the u's. So notice we've got a 7u here, and the answer here they've got 21. That means then that 7u is equal to 21, and so u is 3. And so we can do the same idea with the 2k here. So 2k has to be equal to the 18. And so 2k is 18, therefore k is equal to 9. So u is 3 and k is 9. Make sure put it the right way round as well. Perfect. So we get 9 and 3. Super. Okay, on to some algebraic fractions. Okay, so this doesn't look like a very nice one, but we just use the normal procedure. So first of all, if I take the top here, I can take, what can I take out? So I can take a 5 and a p, okay, because I've got a p in common and a 5 in common, and then work backwards. So what do I multiply p by to get p squared? Well, p. What do I multiply 5p by to get minus 20p? Minus 4. And then we do the same at the bottom. So there's a 2 in common. And then I can see where we're going with this. So what do we multiply 2 by to get 2p squared? Just p squared. What do we multiply 2 by to get minus 32? Minus 16. And notice the bottom here is in a very special form that you really need to be aware of. We call it DOTS, difference of two squares. What does that mean? Well, since these are both square numbers, so 16 is just 4 squared, we can write this as p minus 4, p plus 4, and now we can cancel top and bottom, and that gives us then 5p over p plus 4 for our 3 marks. Nice little question. I forgot to put the 2 in. Oh, look at that. I forgot to put the 2. Don't do that. Don't do that in the exam. Again, as you can see here, you can keep it in factorized form, which is what I'd recommend, or expand it out as well. Okay, question 22. So we've got some vectors here. So diagram shows triangle OPT. Diagram OT is T, so the whole thing is T. OP is P. OK to KT is 2, the ratio 2 to 1. So I usually write this in straight away. So this vector now is 2/3 of t, and this here is 1/3 of t. Okay, and TL to LP is also okay, but I don't know the vector TP yet, but I probably will work that out very soon. Okay, find in terms of T and P in its simplest form PL. So this part here. Okay, yeah, so exactly that. So before we work anything out, we need to work out PT. We take the long way around. So we need to go from P to O and O to T. So P to O, we're going against the arrow, so that's going to be minus P. And then OT, that's just going to be T. So that's our vector from P to T, but we want P to L, which is, as it says in the ratio here, is going to be 1/3. So it's ratio 2 to 1, so 1/3 of what we just worked out, so PT. So we get 1/3 minus P plus T, which we could expand out here, which it probably wants us to do. So that gives us this. So minus 1/3 P plus 1/3 T. Yeah, again, both answers are absolutely fine here. And now we want to work out KL. Okay. So I think to go from KL, we want to go from K to T and then T to L. Now K to T we already know, that's 1/3 T. Now T to L is the not so nice part here, because we can say that L to T going up this way is 2/3 of what we worked out, PT. So 2/3 of minus P plus T, but we're going not L to T, but T to L. So T to L, we reverse the signs around, and so we have 2/3 of P minus T. So that means we get 1/3 T plus 2/3 of P minus T. So that means we get 2/3 P and then 1/3 T minus 2/3 T, that's minus 1/3 T. So in non-bracket form, which we could also factorize this as well, but I've left it in this form here without the brackets in, which is perfectly fine. So key thing here is just watch out the order. Instead of going from L to T, we go from T to L, and the way that we deal with that is just flip the signs. So go minus P to plus P and then T to minus T. Now usually what's more tricky in these questions is something like this, yeah. So KL, oh yeah, that line there, is extended to a point M. Okay, so O to P. So imagine I draw this out, and we've got this vector, and it's going to cross here. Okay, so Km minus 2/3 T plus 4/3. Show that M lies on OP extended. Now OP is an interesting vector here because it has no T value, because OP is just P. So it's just equal to some KP, we don't know what that is, but there's no T component. Yeah, so if we go from O to M, what other ways do we have to get to O to M? So in order to get there, we could go O to M, which you could also follow the straight line here, is also O to K and then k to m, so taking the longer way round. Now OK is equal to 2/3 t. Km we're told in the question, so that's minus 2/3 t plus 4/3 p. Aha, and now the t's cancel here, and so we're left with 4/3 p, and so by definition must lie on OP extended. So by taking this long route, the t's disappear, in which case we're just left with a vector in terms of p, which by definition has to be that horizontal line at the bottom. So you can see the mark scheme here. The key thing was realizing you can take this long way round for question 22. Okay, on to question 23. So Sergey here walked 7.9 kilometers, correct to the nearest 100 meters. So we've got upper and lower bounds here. Okay. And the walk takes 133 minutes, correct to the nearest minute. Calculate the maximum possible average speed into Sergey's walk. And we've got kilometers per hour. So as soon as I see this, I want to change this into hours. Now, notice correct to nearest minutes is going to be between 132.5 and 133.5, our bounds. We're going to be using the formula for speed, which is equal to distance over time. And we're looking for the maximum possible speed. Okay. So you want the maximum possible speed. This is where you have to be careful with the fraction idea. So if we want maximum speed, we want the biggest amount of distance, so max distance over the shortest or minimum amount of time taken. Okay, so imagine you can go a huge distance over a short amount of time and your speed is going to be higher essentially. Okay, so max distance, so nearest 100 meters. So we've got it in kilometers already. So it's going to be between 7.89 and 7.91. And then the time, yeah, this is in minutes at the moment, so 132.5, 33.5. We want the minimum time, so this one. We want the maximum distance, so this one. So max will be, this is in the right units, and this is not in the right units. So we have 132.5 minutes, and we want that in hours. So it's going to be 2 hours. And 12.5 minutes out of 60. Okay, that's nice numbers. So we can use the calculator here. What is 12.5 divided by 60? 5/24. Okay, so we want 7.91 divided by 2 and 5/24. Put this into the calculator, 7.91 divided by, what's that as an improper fraction? 48 plus 5, that's 53, so 53 divided by 24, and that gives us as a decimal 3.581, ... Again, they're happy just to go 3.6 here, kilometers per hour. So key thing to realize here is when you want maximum speed, you want the maximum distance over the minimum time possible. So you want the lowest amount of time but the biggest amount of distance. And then the key thing is to change this into minutes, into hours. And so get it as 2 and 5/24. So a lot of different parts of that question. You can see why it's right towards the end of the paper here. Okay. Right, question 24 here. So the straight line y equals 2x plus 1 intersects a curve. Again, as soon as I see intersects, we need to do some substitution here. So I'm going to put sub at the points A and B, find the coordinates of A and B. So the way we do this is we can replace the y here with 2x plus 1. So we can say 2x plus 1 is equal to x squared plus 3x minus 4. Because if they intersect, then the y values have to be the same. And this is just a quadratic to solve. So bring everything to one side. So we're going to minus 2x on both sides. We're going to minus 1 on both sides. That gives us x squared. 3x minus 2x is plus x. Minus 4 minus 1 is minus 5 equals 0. And then you go, oh no, it's not going to factorize, because you see it's correct to 2 decimal places, which means we're going to have to use the quadratic formula. So x equals minus b, so minus 1. It's always like, oh no. So 1 squared is 1 minus 4 times 1 times minus 5, all over 2a, so all over 2. So how can we simplify this down? Minus 5 times 4 is minus 20. 2 minus make a plus, so we get square root of 21 over 2. Oh, I always kind of dread this when you can't use quicker methods. So let's go to our calculator and pop this in. So let's work out the first one. So we have minus 1 plus root 21 over 2. And that gives us 1.791 ... And we can work out the y value by substituting it into the most easy function. So x is 1.791, substituting in here. This will save us a little bit of time here. So now we can just take 2 times answer plus 1. And that gives us 4.58. as one pair, so 1.79, 4.58, and now we do the second pair. So we have minus 1 minus root 21 over 2. That gives us minus 2.79 ... And again, we can substitute this in. Sure you're liking that sound at this point. 2 times answer, add the 1, minus root 21, that's nice, minus 4.58. So minus 4.58 minus 2.79. So there we are, those are the 2 answers. They've done 2 decimal places as well. That seemed kind of natural to do here. But again, this is a quadratic formula question. You kind of know this because you see this 2 decimal places here. Okay, and if you would like to go through a walkthrough of all things Specimen Paper 2, then do check out the video in front of you. I also have predicted papers in the description.